This is the fifth in a series of quarterly reports that feature progress being made by NASA's Exploration Launch Projects Office, which is developing the ARES 1 crew launch vehicle and designing the ARES 5 cargo launch vehicle. Last quarter, ARES reported on a new material for first stage solid rocket motor insulation, computer simulation of the vehicle's ascent environment, and injector tests conducted on J2X engine hardware. Work continued from last quarter on the facility that will house Marshall's world-class friction stir weld tool. Testing also continued this quarter on the upper stage confidence panels and ARES 1-X roll control system. This quarter, the ARES 1 design underwent significant wind tunnel testing at both Langley Research Center's Unitary Wind Tunnel and Boeing's Polysonic Wind Tunnel. At Langley, tests focused on high-speed flow, simulating speeds from Mach 1.5 up to Mach 4.5. Boeing's tests were run at lower speeds from Mach 0.5 to Mach 1.6. Both wind tunnels also tested a proposed new launch abort system configuration that incorporates an aerodynamic fairing to reduce drag and aeroacoustic noise created by protuberances on the vehicle. As part of the project's ongoing outreach and education efforts, ARES personnel attended the finals of the Team America Rocketry Challenge. At the event, the project unveiled an ARES 1 replica rocket, a 1:100 scale model of the new crew launch vehicle. Through participation in this event, the Exploration Launch Projects Office demonstrates its commitment to inspiring the next generation of rocket scientists and space advocates. At ATK's test facility, a solid rocket motor test firing was conducted in partnership with the Space Shuttle program to qualify the new insulation material and low-temperature O-rings. The test also examined movement of the center segment of the motor for structural sag. These data will help validate the model for the ARES 5-segment motor. Following this test, the T-97 facility will be modified to accommodate the needs of the ARES project. Risk reduction tests are underway on the first stage Ascent Thrust Vector Controller. This controller will translate commands from the flight computer to the nozzle actuators on the first stage, steering the vehicle during ascent. The testing has been a great success, identifying some modifications necessary to the design. Confidence panel testing continues for the ARES 1 upper stage instrument unit. These tests are looking to increase the aspect ratio of the instrument unit's height compared to the structural ribs to reduce the component's weight. Further progress was also made this quarter on the installation of Marshall's robotic friction stir weld tool. The 70,000-pound main column of the robotic tool was delivered to Building 4755, where facilities work had been completed last quarter to receive the one-of-a-kind machine. Once completed, this tool will be used to assemble a number of different upper stage components in the same manner as was developed under the external tank program on the Space Shuttle. The ARES 1 interstage mock-up completed assembly this quarter at Marshall. The mock-up provides full-scale representations of the flight design, providing an accurate representation of the planned flight hardware. This simulator provides a cost-effective means of visualizing and validating the vehicle design, as well as providing insight into the challenges and solutions for future ground support activities. Work began this quarter on Heritage Saturn IVB main propulsion system valves. The team, working from the sole remaining original drawing, have disassembled the LOX and LH2 vent relief valves. The individual components will be thoroughly cleaned and then reassembled for testing later this summer. In addition to advancing work on component development, this provides a valuable training tool for new engineers. Testing is underway on the Apollo Heritage J2 liquid oxygen inducer to verify the component's performance. Scaled water testing can be performed for a fraction of the cost of full-scale testing, and tests can be conducted earlier in the development phase of the project. To better understand the side loads placed on the engine nozzle, airflow testing is underway at Marshall's nozzle test facility. The results of these tests will help engineers optimize the design of the engine nozzle, trimming the engine's weight to allow for larger payloads. Tests to date have used a scale Space Shuttle main engine nozzle, but upcoming tests will transition to a 1:50 scale J2X nozzle. A second round of tests was conducted on the Peacekeeper engine to evaluate its fitness for use as an ARES 1-X roll control system. The decommissioned Peacekeeper hardware will get a new lease on life, saving taxpayers significant expense. The results of this test, combined with those from the previous series reported last quarter, confirm that the Peacekeeper engine can be reconfigured for application on ARES 1-X. Testing began in early June to ensure the suitability of commercially obtainable sensors for use on this first test flight in 2009. All the sensors passed in the first set of tests completed in mid-June. Join us for the next ARES Quarterly Report, which will feature a wind tunnel testing update, the first stage parachute demonstration, and the latest developments on the upper stage and the J2X upper stage engine. For more information about ARES plans and progress, visit us on the web at nasa.gov/ARES.